Okay, so this is the first question on your review. I'm going to look at one part at a time, and we'll go look at the AP rubric as we go through this. So we have a table, so we're going to be working with this table, and let's read through the problem. A zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box, so we're talking about entries, between noon, so here's noon, and 8 p.m. Here's 8 p.m. The number of entries in the box, T hours, so this is the number of entries in the box, T hours after noon, is modeled by a differentiable function E for 0 to 8. Values of E of T in hundreds of entries, so that's important, at various times T are shown in the table above. Part A, use the data in the table to approximate the rate in hundreds of entries per hour at which entries are being deposited at time t equals 6. Show the computations that led to your answer. Okay, so part A. If we want to use Kafka, then what do we know? Remember, this is a brief 2 to 3 word description. What is it that this table up here tells us? Well, when we read this problem, it tells us what we would say is at 0, we have 0 entries. At 2, we have 400 entries. At 5 hours, we have 1,300 entries. At 7 hours, we have 2,100 entries, and at 8 hours, we have 2,300 entries. So that is telling us exactly what the entries are. So this is exactly number of entries. What do we want to know? Well, when we go back and read part A, use the data in the table to approximate the rate. Stop right there. Approximate the rate. We are finding a rate. And it tells us the rate is hundreds of entries per hour. Okay? At time 6. Show the computations that led to your answer. Formula. Well, if we want to go from a stationary number to a rate, that means that we're going to have to go down our list, which is a derivative. So to find the derivative without an equation, we have no equation. There's no equation to take the derivative of, but we do have a table. So our table, to find the derivative, we're looking for the slope at 6. So we're going to use f of b minus f of a all over b minus a. So that's our calculus. Our calculus is that we are taking the derivative, and we are using this formula. So to get our answer, we're going to plug this in, and we want at t equals 6. So at t equals 6, 6 would be right here. So 6 is not on our table. So if 6 isn't on our table, we need to use whatever is closest to that. Well, that would be 5 and 7. So 5 would be A and 7 would be B. So we would do f of 7 minus f of 5 all over 7 minus 5. F of 7 is 21. F of 5 is 13. So we have 21 minus 13 over 7 minus 5. That is 8 over 2, which is 4. Now let's make sure this is a word problem. So approximate the rate in hundreds of entries per hour. So we need to go write that down here. Hundreds of entries per hour. And that is our final answer here for part A. So, part B. Part B says use a trapezoidal sum with 4 subintervals given by the table to approximate the value of 1/8 times this integral. Using correct units, explain the meaning of 1/8, the integral from 0 to 8 e of t dt, in terms of the number of entries. So let's go down here and look at part B. So part B says that we're using a trapezoidal sum. So that means that we're going to do the area of trapezoids. So area of a trapezoid is 1/2 times the height times base 1 plus base 2. And we want to find the integral from 0 to 8 e of t dt. And it's not just that integral. So look what they have. They want us to multiply this integral by 1/8. So we do that, we can get this area by adding up sum of the trapezoids. So when we do that, we will have 1/8 because of this 1/8. It's just going to stay out front. 1/2 times the height times base 1 plus base 2. Plus, and we'll do that for all four. Our first trapezoid will be from 0 to 2, then 2 to 5, then 5 to 7, then 7 to 8. So the height is the difference in these values. So the height of my first trapezoid is 2, height of my second is 3, then 2, then 1. And then my bases, here's base 1 and base 2 for my first trapezoid. So it has a height of 2, and these are the bases. My second trapezoid has a height of 3, and base 1 is 4, and base 2 is 13. So when you write that sum out, you'll have 1/2 times 2, 0 plus 4, plus 1/2 times 3 times 4 plus 13, plus 1/2 times 2 times 13 plus 21, plus 1/2 times 1 times 21 plus 23. When we add all this up, put it in our calculator, this is what we're going to get. You get 10.688. 3 places after our decimal point because we are in AP Calculus, and that's how we need to be, how specific we need to be. So there's our number that integral equals. So we've done this. Using correct units, explain the meaning of this in terms of the number of entries. So what does this integral have to do with the number of entries? Well, when we take an integral and we have a fraction out front, that means, it means a couple things, but in this specific case, if we are looking from 0 to 8, this would be 1/8 minus 0, the integral from 0 to 8 of e of t dt. Once you recognize that pattern tells us the average value. That is our average value integral. So this integral, 1/8 from 0 to 8 e of t dt, is the average number of, and we have to be careful here. So we have average number of entries, but remember we're talking about hundreds of entries. So this is the average number of hundreds of entries in the box between what did they say it was between? They said it was between 0 and 8, which if we look up at our original problem, we're talking about 0 to 8. We're talking about noon to 8 p.m. Noon and 8 p.m. So let's check these first two against the rubric. Our first part, we ended up with 400 of entries per hour. When we go over here and look at the rubric, so here's part A up here. It says E prime of 6 is approximately equal to E of 7 minus E of 5 over 7 minus 5. And for part A, you just get one point for your answer. And they said that part of your answer is saying hundreds of entries per hour. So on the AP exam, they're going to look to see if you did this. It's okay if this is E and you wrote F. They know what you mean, okay? In the future, if you remember, you can write E, but if you don't, that won't count completely against you. And we said 400 entries per hour, so we got our point for that. The second one, we did all of these. We just plugged them in. Here's our 1/2 is down here, all these dividing by 2s, okay? And our heights are here, 2, 3, 2, and 1. That's what we had on our paper. And we added E of 0 and 2, and then 2 and 5, and then 5 and 7, and then 7 and 8. When we added all that up, we rounded to 10.688. So if you have 10.688 or 10.687, both of those were correct and would give you that approximation point. So the trapezoidal sum is here, plugging things in. The approximation is here. But remember, if you don't write E of 5, if you just go ahead and write a value in there, so whether that was like 4, I think, or 13, that's what you're plugging in, and you could leave your answer there. And then finally, they say 1/8, the integral from 0 to 8, E of t dt, is the average number of hundreds of entries in the box between noon and 8 p.m. You could probably also say between t equals 0 and t equals 8. If you didn't say noon and 8 p.m., I think that would still be okay. So let's do C and D. So C. Part C. C says we are looking at 8 p.m., volunteers began to process the entries. They processed the entries at a rate, so processed at a rate of P of T equals this equation. So there's an equation. Hundreds of entries per hour between 8 and 12. According to the model, how many entries had not yet been processed by midnight? So what do we know? Well, we know a rate. The rate at which they're being processed. What do we want to know? We want to know how many were not processed. So we kind of need to know the opposite of the information that they gave us. The formula or equation. In this case, they gave us an equation, P of T equals T cubed minus 30 T squared plus 298 T minus 976. Sorry, just 976. There's not a T after that. Okay. And to find how many were not processed with the rate, figuring out how many were processed, we would need to do the number entered. So how many total? Minus the number processed. How many did we get? How many did we process? And then we will be able to get how many were not processed. So when we look back up at the problem, this tells us how many entries there were. Well, at the end of the day, there were 2,300 entries. So we started with 23. And to get the number processed, we're going to get it from this equation. And what we're going to do, this is our calculus decision. Well, if we have a rate and we want a number from that, we are going to integrate. So we're going to integrate, and they told us that this is the process from 8 to 12, t cubed minus 30 t squared plus 298 t minus 976 dt. Okay, this is where our notation really matters. And we're going to end up subtracting that from 23 because 2,300 were processed, and this equation is in hundreds per hour. Okay. So from here, we just have to integrate that. So we're going to leave the, to get our answer, we're going to leave that 23 out front minus, so from here, we are going to integrate. When we integrate, we get t to the 4th over 4 minus 10t cubed plus 149 t squared minus 976 t from 8 to 12. From there, we do f of b minus f of a. So we have 23 minus, we'll leave that alone for now. We plug in 12 to the 4th divided by 4. Minus 10 times 12 cubed plus 149 times 12 squared minus 976 times 12. Okay, minus f of b minus f of a, plugging in the 8 to the 4th over 4, minus 10 times 8 cubed plus 149 times 8 squared minus 976 times 8. Whew. Okay, now we have, leave the 23, we're not there yet. This will be 5,184 minus 17,280 plus 21,456 minus 11,712 minus 1024 plus 5120 minus, that's a 0, 9,536 plus 7,808. Because what I did, I plugged each of these into my calculator. I also distributed this negative to get these signs back here. So this became a negative, this one became positive, this became positive, or negative, I'm sorry, that's a negative. The positive became negative, negative became positive when I distributed that. Now, when you put those huge numbers in your calculator, you get 16. So there were 700 entries. Sorry, my pen is going kind of crazy. Now, last part, part D. So, part D says, according to the model from part C, so here's the model, is this equation. At what time were the entries being processed most quickly? Justify your answer. Okay, so D. We know P of T, which is a rate. We want the rate, how quickly is that changing? So we want a rate of a rate. Okay? So our formula is T cubed minus 30T squared plus 298T minus 976. That's a 9. Well, if we want to go from a rate to a rate of a rate, that's a derivative. To find where it's going most quickly, we have to take that derivative and set it equal to 0. So let's take a derivative of our equation. P prime of t is 3t squared minus 60t plus 298. And we need to set that equal to 0. Now, if you really had the deep desire to factor this, I don't even know if it's factorable. I didn't even really try. I started to, and then I got overwhelmed. So if we are setting this equal to 0 and we want to find the answers to a quadratic equation, guess what? That's why for so many years, your math teachers talked and talked and talked about the quadratic formula, because that will solve any quadratic equation that you come across. And yes, this might be on your AP exam, the quadratic formula. So remember, this is A, this is B, and this is C. So when we get these solutions, we would have B is negative 60, so negative of negative 60 is positive 60, plus and minus the square root of negative 60 squared minus 4 times A times C all over 2 times C, A, which is 3. Negative B plus or minus square root of B squared minus 4AC all over 2A. Look up the songs, memorize it. You will use it for the rest of your math career if you continue in this class or if you go to a different math class. So, next, I put this in my calculator. I simplified it down. I did under the square root first, so that gave me 60 plus and minus the square root of 3600 minus 35. That's a 3. 576. Oh, this smart notebook is getting really slow. I'm sorry. All over 6. And that gives me 60 plus or minus the square root of 24 all over 6. And when I plug that in my calculator, I got 10.816 and 9.184 when I did the plus and then the minus. Okay. From there, we are trying to figure out, what the heck are we trying to figure out? Well, when we go all the way up here, at what time, so our answer is going to be a T, are the entries being processed most quickly? Well, when we come across the problem like this, they're either where it's equal to 0 or the end points. The end points of the processing are 8 and 0. So we look at those. And T, it starts at 8. 9.184 is next. Then 10.816 is next. And then 12 comes in at the end. And so processed P of T. When is the rate the highest? Well, when we plug in these numbers, we'll get a rate. The highest one is the when it's being processed most quickly. When you plug in 8 to p of t, not the derivative, but the original p of t, the t cubed minus 30t squared plus 298t minus 978. You get 0. You get 5.088. And you get 2.911. And you get 8. Well, the highest number is this last one here. So the entries says justify your answer. So the entries, E-N-T-E-R. No, that's not how you spell it. I'm sorry. Oh boy. So entries. Wow, this is really not working well, is it? Sorry about that. Processed. Wow. This does not want me to write. Processed most quickly at time t equals 12. And all my math justifies it. That shows the work. So let's glance at the rubric and then we'll be done with this. So for C, it says that we need to make sure that we have an integral, which we did end up doing the integral. Okay, and when we did that integral, we got 7 and we said 100 entries, so we got that answer as well. And then it said we needed to set the derivative equal to 0, and we got these 2 answers. So they gave a bunch of decimals. If we didn't give as many decimals, that's fine. Remember, our rule is 3 decimal points. So we identified the candidates. We had 8, we had 9.18, and we had 10.81. Okay. Answer with justification, we said it was at time equals 0, and we said it was happening most quickly at time equals, or t equals 12. I'm sorry, I just said 0, but I meant 12 because that's the number that's there. Okay. And that is, we got all of our points. So you should go through and see what kind of points you got on this FRQ.